Good afternoon. Today we will see on circle theorem 6. What is the theorem 6 says? When I was explaining regarding the basic terms, I told you what is the segment. Word told. What is meant by segment? The region bounded between chord and the arc is called as segment. So what we have to prove that angles in the same segment of a circle are equal. We have to prove that angles in the same segment of a circle are equal. So what is given to us? O is the center of the circle and two what to call it as angles are there. APB is the arc, same arc. The angle should be subtended by the same arc. You can see APB is the arc. It subtends angle ACB on the circumference and angle ADB on the circumference. So what you will write down given? O is the center of this circle. Okay, arc APB subtends angle ACB and angle ADB on the circumference. That is the given. Once again I am repeating. What is given? O is the center of the circle. Arc APB subtends angle ACB and angle ADB on the circumference. So that is your what to call it as given. So let us write down given. So what is given? Arc APB subtends angle ACB, okay, ACB and angle ADB, ADB at C and D on the circumference. So this is your given. Okay. Now, what he says that those angles are equal. That is, you have to prove. Which angles? Angle ACB and angle ADB. They are equal. You have to prove that. So, what you have to prove? What you have to prove? Angle ACB is equal to angle ADB. Okay. You can prove this only by doing construction. So, construction. What is the construction over here? The construction is that you have to join the center with A and the center with B. That is, you are going to join OA and OB. So, I am joining C. The dotted line. So, what is the construction? Join OA and OB. That is the construction. So, join OA and OB. Okay. Now let us see the proof. What is the proof? In theorem 5 we saw that if an arc subtends an angle at the center and subtends an angle on the circumference, the relation is there. What is the relationship? The angle subtended at the center by the arc is equal to twice the angle subtended by the same arc on the circumference. That theorem 5 we are going to use. So, AOB and ACB. AOB is the angle made at the center. ACB is the angle made on the circumference. So, what we can show that angle AOB is equal to twice angle ACB. So, what we will take? Angle AOB is equal to twice angle ACB. The reason, what is the reason? Angle made by arc at the center is twice that made on circumference. So this is the reason. Angle made by arc is twice that made on circumference. So let us take now ADB and AOB. AOB is the angle at the center and ADB is angle on the circumference. What relationship we can show? The same relationship we can show. Like this, you take it as equation number 1. So what we can take it as? Angle AOB is equal to twice angle ADB. What is the reason? Same reason. Angle made by arc at center is twice the angle made at circumference. This is your equation number 2. Same reason. Okay. AOB is a angle made at the center. ACB is angle made at the circumference. So angle AOB is equal to twice angle ACB. Angle AOB is equal to twice angle ACB. Here also, AOB is made at the center. ADB is made at on the circumference. So what you will get? Angle AOB is equal to twice angle ADB. See equation 1 and equation 2. Here is also angle AOB. Here is also angle AOB. So what you can prove that? From equation 1 and equation 2, what you can prove that? Twice angle ACB is equal to twice angle ADB. 2 and 2 cancels. So what you are able to prove that? Angle ACB is equal to angle ADB. That means how many angles are there in the same segment? All the angles will be equal. So therefore, angle ACB is equal to angle ADB. Hence, proved. So you have proved your theorem. So once again we will see what we have to do in this theorem. So this is theorem number 6. Angles in the same segment of a circle are equal. So what you are going to do here? Given O is the center of the circle. That is, okay, arc APB subtends angle ACB and angle ADB on the circumference. Got it up? Then what you have to prove? Angle ACB is equal to angle ADB. What you are going to do? Construction. Join OA and OB. Proof. What you will take? Angle made by the arc at the center is double the angle made by the arc on the circumference. That we are going to take. That is theorem number 5. So what we told that angle AOB is made at the center, angle ACB is made on the circumference. Therefore, angle AOB is equal to twice angle ACB. Here also we can take angle AOB is made at the center, angle ADB is made on the circumference. Therefore, angle AOB is equal to twice angle ADB. This is equation number 1. Equation number 2. Compare. What will happen? Axiom 1. Things which are equal to same thing are equal to one another. So twice angle ACB is equal to twice angle ADB. 2 cancels. Therefore, angle ACB is equal to angle ADB. Hence, you have proved your theorem. So this is theorem number 6. Let us see the first example in this. In the figure, PQ is equal to PR. PQ is equal to PR. And angle PRQ is given 70 degree. Find angle QAR. You can see that arc QR subtends angle QPR on circumference also and QAR on circumference also. Just now in theorem 6 we saw angle subtended in the same segment. So this is the same segment. We are equal. Means if we get how much is QPR, we can get QAR also. Why? Because angle QPR is equal to angle QAR. How to find out angle P in this? Now look here. PQR, PQ is equal to PR. Okay. Sides are equal means the opposite angles are also equal. Means angle PRQ is equal to angle PQR. So that also became 70 degree. In a triangle, sum of all the three angles is how much? 180 degree. That concept we will use over here. We will find out the angle P and then we will show that it is equal to angle A. So, what we are going to write it down? In triangle PQR, what is given to us? PQ is equal to PR. Bracket, it is given in the sum. Therefore, what happened? Angle PRQ is equal to angle PQR is equal to 70 degree. Why? Because what it is? Angles opposite to same sides are equal. So that is what the concept over here. Because PQ and P are the same sides, it's equal side. So angles opposite to same sides are equal. Okay. This two became 70 degree. Now according to your interior angle theorem, what does the interior angle theorem says? That sum of all the three angles is 180 degree. That we will write it down. Angle PRQ plus angle PQR plus angle QPR is equal to 180 degree. These two angles, we know how much each angle is 70 degree. So 70 degree plus 70 degree plus what we call it as angle QPR is equal to 180 degree. How much is 70 plus 70? It is 140 degree plus angle QPR is equal to 180 degree. Therefore, angle QPR is equal to 180 minus 140, that is equal to 40 degree. So that means QPR you got. Now you see QR is a arc which subtends angle QPR on circumference also and angle QAR on the circumference also. And both are in the same segment according to theorem 6. Angles in the same segment are equal. So therefore angle QPR is equal to angle QAR is equal to how much it is given? Is equal to 40 degree. Reason, important, angles in same segment are equal. That is the reason why we got angle QPR is equal to angle QAR is equal to 40 degree. What is the reason? Angles in the same segment are equal. Once again, let us see. PRQ is given how much it is? 70 degree. PQ is equal to PR, means it is an isosceles triangle. In isosceles triangle, what happens? If opposite sides are equal, then the opposite angles are also equal. So, in triangle PQR, PQ is equal to PR, given therefore angle PRQ is equal to angle PQR, there is an angle opposite to the equal sides are equal. So, sum of all the three angles, interior angle theorem, what does it say? It is 180. So, angle PRQ plus angle PQR plus angle QPR is equal to 180. Substitute the values of this. 70 plus 70 is equal to angle QPR is equal to 180. 140 plus angle QPR is equal to 180. Angle QPR is equal to 180 minus 140. That is equal to 40 degree. Angles in the same segment. Which are in the same segment? QPR and QAR. Angles in the same segment. If QPR becomes 40, what will become QAR? QAR also became 40. You have to find out what is angle QAR. This is how you have to solve the sum. Let us go to the second worked example. What does the second worked example say? Let us see. In the figure, a circle passes through A, B, C, D. A, B, C, D means all these 4 points are lying on the circle. Okay. Then angle BAC, he has given it as 67 degree. So angle BAC is equal to 67 degree. Find what is angle DBC and plus angle DCB. You have to find out that. Okay. Now you can see that arc BC subtends angle BAC and angle BDC on the circumference, and both are present in the same segment. So what will happen? The angles in the same segment are equal. So angle BAC is equal to angle BDC. You can use theorem 6. So what you are going to do, the solution what you are going to do, angle BAC is equal to angle BDC is equal to how much it is? 67 degree. Reason, angles in same segment are equal. That is the reason. Okay. Now we ask you to find out angle DBC plus angle DCB. They are the angles of the triangle DBC. One angle we have got. Interior angle theorem can be used? Yes. So what will I write down? In triangle DBC, angle BDC is equal to 67 degree. Then what will I write down? Angle DBC plus angle DCB plus angle BDC is equal to 180 degree. This is what interior angle theorem. Okay. Now, whose value we know? BDC value we know. So, BDC value we write it down. So, angle DBC plus angle DCB plus 67 degree is equal to 180 degree. So, what is angle DBC plus angle DCB is equal to? Angle DBC plus angle DCB is equal to 180 degree minus 67. Let us subtract 180 minus 67. 10, this will become 7. 10 minus 7 is 3. 7 minus 6 is 1. 1. So how much you got it as? Angle DBC plus angle DCB is equal to 130 degree. What you want to find out? So angle DBC plus angle DCB is how much? You got it as 113 degree. So easy it is. You are using interior angle theorem and angles in same segment are equal. So first we will see, that is BDC and BAC. They are both are present in the same segment. So according to the theorem, angles in same segment are equal. We can show that angle BAC is equal to angle BDC is equal to 67 degree. Okay. Now, he tells us to find out angle DBC plus angle DCB. See where they are? DBC, DCB. They are the angles of the triangle DBC. Using interior angle theorem, we can find out what is the sum of angle DBC and angle DCB. That only we have done. So, in triangle DBC, angle BDC is equal to 67 degree. Angle DBC plus angle DCB plus angle BDC is equal to 180 degree. So what will happen? Angle DBC plus angle DCB value is given plus 67 degree is equal to 180 degree. Take plus 67 on the other side, it will become minus 67. So 180 minus 67 is 113. So angle DBC plus angle DCB, you got it as 113 degree. This is how we have to solve problem number 2. Now, let us see work at example 3. In the following figure, O is the center of the circle and find the value of A, means this value you have to find out. Can you see that? Angle ACB and angle ADB, they are angle in the same segment. If I can get angle ADB, I can say that it is equal to angle ACB. Okay. Now look here. BD is the diameter. And I have told you that the diameter, when it makes an angle, it makes right angle on the circumference. Means angle BAD is equal to 90 degree. What you call it as? Angle BAD is equal to 90 degree. Why? Because BD is the diameter. So we will write it down our solution. BD is the diameter. Therefore, angle BAD is equal to 90 degree. Angle made by semicircle. What will diameter do? Divides the circle into two equal parts. So angle made by semicircle is what? Right angle. So right angle means how much? It is 90 degrees. We want what is BDA. Now look here. In triangle BAD, angle BAD we got, angle ABD we got. Can't we find out what is angle ADB? Interior angle theorem. So that we will use. In triangle BAB, angle BAD is equal to 90 degree. We proved now. Next angle what is given? Angle ABD is equal to 35 degree. Okay. Now we will take interior angle theorem. Angle BAD plus angle ABD plus angle ADB is equal to 180 degree. So what you will get if you take substitute the values? What is angle BAD? 90 degree plus. What is angle ABD? 35 degree plus angle ADB is equal to 180 degree. 90 plus 35. So how much you got? 125 degree plus angle ADB is equal to 180 degree. Therefore, angle ADB is equal to 180 minus 125. So let us subtract 180 degree, 125. 10, 7. 10 minus 5 is 5. 7 minus 2 is 5. So you got it as therefore angle ADB is equal to 55 degree. ADB. ADB is equal to ACB is equal to A is given. What are they? Angles in the same segment. So therefore angle ADB is equal to angle ACB is equal to A is equal to 55 degree. Reason, angles in the same segment are equal. That is what we have used over here. So came to know what it is. Once again we will try to understand what it is. See, in the circle O is the center of the circle and BD is the diameter which divides the circle into two equal parts. We call it as semicircle. Remember one thing in mind. Angles in the semicircle is always a right angle. So angle BAD become 90 degree because angle made by semicircle is right angle. In a triangle, if we get two angles, can't we find a third angle? Yes, by using what? Interior angle theorem. So angle BAD is 90, angle ABD is 35. So angle BAD plus angle ABD plus angle ADB is equal to 180 degree. Therefore 90 degree plus 35 degree plus angle ADB is equal to 180 degree. So what will be angle ADB? 190 plus 30 is 125 plus ADB is equal to 180 degree. Angle ADB is equal to 180 minus 125. Angle ADB is equal to 55 degree. But we know that angle ADB and angle ACB, that is your angle A, is in the same segment. So angle ADB is equal to angle ACB is equal to A is equal to 55 degree. So angles in the same segment are equal. So 3 examples I have solved, but that is based on theorem number 6. So bye and thank you.